Encapsulation. There are two views of an object. Internal, the details of the variables and methods of the class that defines it. External, the services that the object provides and how the object interacts with the rest of the system. From the external view, an object is an encapsulated entity providing a set of specific services. These services define the interface of the object. One object, called the client, may use another object for its services it provides. The client of the object may request its services, called its methods, but it should not have to be aware of how those services are accomplished. Any changes to the object state, its variables, should be made by the object's methods. We should make it difficult, if not impossible, for a client to access the object's variables directly. That is, an object should be self-governing. An encapsulated object can be thought of as a black box. Its internal workings are hidden from the client. The client invokes the interface methods, and they manage the instance data. So here they're giving you a diagram of what an object of a particular class looks like. So here would be the instance data, and then we have the methods. Now the methods would directly modify and access the instance data, but through these methods, if these methods are declared to be public, a client will request those services. So for instance, like for our die class, this would be the get face value, set face value, and enroll method. And those are the methods that act on the data. In Java, we accomplish encapsulation through the appropriate use of visibility modifiers. A modifier is a Java reserved word that specifies particular characteristics of a method or data. We've used the final modifier to define constants. Java has three visibility modifiers: public, protected, and private. The protected modifier involves inheritance. We'll discuss that in Java 2. Members of a class that are declared with public visibility can be accessed anywhere. Members of a class that are declared with private visibility can be referenced only within the class. Members declared without visibility have default visibility and can be referenced by any class within the same package. We won't really discuss this. This is actually a topic that we'll discuss more in Java 2. An overview of all Java modifiers is presented in Appendix E of the book. Public variables violate encapsulation because they allow a client to modify values directly. Therefore, instance data variables should not be declared with public visibility. It is acceptable to give a constant public visibility which allows it to be used outside of the class. Public constants do not violate encapsulation because although the client can access it, its value cannot be changed. And this is what I did in my die class. If you look back at the die class, because these are constants, I went ahead and made them public. That means that these values can be accessed directly, but they can't be changed because they're declared to be constant. And I did that using the final modifier. Methods that provide the object services are declared with public visibility so that they can be invoked by the clients. Public methods are called service methods. A method created simply to assist a service method is called a support method. Since a support method is not intended to be called by the client, it should not be declared with public visibility. So what they're talking about with a support method is if I had a method that does some type of work within my class, but I didn't want it to actually be a service that is invoked through my object, then I would declare with private visibility. Now, making a method have private visibility just means it can only be called within the class. And here's a table that explains encapsulation. So if a variable is declared public, it violates encapsulation. If a method is declared public, it provides a service to clients. If variables are declared private, it enforces encapsulation. If a method is declared private, it's considered to be a support method, meaning you can only invoke that method within the class. Accessors and mutators. This is basically just getters and setters, but the book also calls them accessors and mutators because they access the data and change the data. So the accessor would be the getter and the mutator would be the setter. Because instance data is private, a class usually provides services to access and modify data values. An accessor method returns the current value of the variable. A mutator method changes the value of the variable. The names of accessor and mutator methods take the form of getX, setX, respectively, where X is the name of the variable. They are sometimes called getters and setters. Mutator restrictions. The use of mutators gives the class designer the ability to restrict a client's options to modify an object state. A mutator is often designed so that the values of the variables can only be set within particular limits. For example, the set face value mutator of the die class should restrict the value to a valid range of 1 to max. We will see in Chapter 5 how such restrictions can be implemented. So if you look at the die class that I created, in my setter, I did restrict the values of the face value. So I'm doing a check to prevent the value from being set outside of the range of 1 to 6, which is the min and the max. So the whole purpose of encapsulation is to prevent your data from being set to something that doesn't make any sense at all. And this is something that's very important because you never want your data to be set to something that doesn't make sense. Now, depending on the type of program that you're creating, restricting your data is something that's very important. Quick check. Why was the face value variable declared as private in the die class? It was declared private to enforce encapsulation. Why is it okay to declare max as public in the die class? So it's okay to be public because the value cannot be changed. And here are the answers to these questions. By making it private, the die object controls its own data and allows it to be modified only by well-defined operations it provides. For the constant, they say the max is a constant, its value cannot be changed, therefore there is no violation of encapsulation.